fail. You fail. So you know, Chandler, most of my videos have 0 views, so you're not really becoming very YouTube famous. How is a trapezoid different than a parallelogram? Sydney. Only one set of parallel lines. It's still a quadrilateral, but it only has one set of parallel sides. Exactly one pair. Because if it was more than one pair, it would be parallelogram. We most of the time think of a parallelogram like this, with the bases on the top and the bottom, but oh, that looks good. That was very quick. That was very quick. Is that a parallelogram? Not a parallelogram. A trapezoid was a trick question. This is what I meant to draw, but I failed at drawing it. Does it have a set of parallel lines? Aren't these the parallel sides? So I just want to say, a lot of times we think of a parallelogram, gosh, why am I saying that? We think of a trapezoid like this, where the two parallel sides and the other two sides coming like this. But this is also a trapezoid, because here's my parallel sides, and then although these aren't both coming in like that, those are definitely not parallel sides. The parallel sides could be like this, or they could be on the top and the bottom. But just know, the parallel sides are always called the bases. Alright, so this is called like base 1, base 2. We used to like formula the trapezoid and talk about that. So both of those are parallelograms. So we're going to talk. I said parallelogram again. There's a lot of things about trapezoids, which is why the notes seem so long, is because there's a lot of theorems about trapezoids, special types of trapezoids. And then we're going to talk about kites as our last type of quadrilateral. Probably kite is maybe the least popular quadrilateral. But what do you think a kite is? It looks like a kite, right? So if you drew a kite, dang it just makes it look the same every time. Alright, that looks like a kite, right? What do you think the definition, the math definition of a kite is? It's a quadrilateral with exactly 2 pairs of consecutive congruent sides, which means like these 2 sides. It means like these 2 sides are congruent and these 2 sides are congruent. So it's not opposite sides are congruent, it's consecutive sides are congruent.
Okay, please do it.
It doesn't do anything unless I make a close shape. So if I try to make a 4, it should be right.
Yeah.
If Chandler can be good the rest of the hour. Okay, so trapezoids and kites. We don't have a lot of things about diagonals of them and lots of properties of them, but if we talk about a special type of trapezoid, then we do have a relationship. So what do you think the definition of an isosceles trapezoid is? What does isosceles mean in terms? Isosceles triangle is what 2 sides. If the legs of a trapezoid are congruent. So let's talk about which side is which, right? It's a lot of work to make things disappear and reappear. So I told you that the parallel sides are called the bases, right? So that means the non-parallel sides are called the legs. So an isosceles trapezoid is if the non-parallel sides are congruent. And if you have an isosceles trapezoid, then we can say all these theorems are true about it. Which means that maybe so notice, again, I didn't make you fill any blanks in here. I just want you to know what it says. It says if a trapezoid isosceles, then each pair of base angles is congruent. So the base angles are the angles that come from each base. So notice that that means that this angle is congruent to this angle, and that angle F would be congruent to angle G. So it's not that opposite angles are congruent, it's just that the angles on each base would be congruent. And then, theorem 6.22, we have 22 theorems. It says if you know that one pair of congruent base angles, then that's enough to know that it's a trapezoid. Ooh, you see how they change it up on this one? Right, so look, here's my parallel sides. So the base angles, that's why you might want to redraw the picture. Maybe even rewrite the angle L, here's angle M. The base is side LM, even though it's turned on its side, but that's the parallel side. So if you just know that those two angles are congruent, then that's enough to determine that the angle, the trapezoid, is isosceles. And then one more thing about diagonals here. If a trapezoid is isosceles if and only if its diagonals are congruent. So not only are the diagonals congruent in a rectangle, it also means the diagonals are congruent in a square. An isosceles trapezoid also has congruent diagonals. So notice QT is congruent to RS. Those are the legs. The opposite sides are parallel. And that means that RT and QS are congruent. So oh dear. So just like everything else we've done in this chapter, now they can give you pictures and they can give you information, and based on what it is, you should be able to solve for the missing information, whether it's numbers or whether it's letters. So it says each side of the basket shown is an isosceles trapezoid if the angle FGH equals 124 degrees, FI equals 9.8 feet, and IG equals 4.3 feet. Find the measure of angle EFG. So I'll give you a minute. See if you can fill stuff out and see if you can figure out the answer based on what we know with trapezoids. Yes, is that what we know? Anybody got any ideas? Allie? So because we know the diagonals are congruent, right? I don't know. Maybe there's a way to go. What do you think, Grace? Base angles are congruent. What's the base angle to angle G? Which angle is its base angle? So if this is 124, this is how I would go. If this is 124, that also means this is 124. But that means these two are also the same, but they don't necessarily equal 124, right? Do trapezoids add up to 360 degrees? It's a quadrilateral, right? It's a four-sided shape, so yes. So just to confuse you, or maybe it's for part B. So if I take that, right? 112, is that true? So does that mean this angle equals 112?
No.
Then I would divide by 2, because I have to split it between those two, right? So that would be 56 degrees.
Yes.
I think it's 56. Ooh, could you do consecutive interior angles? Because it's parallel lines, yes. So remember that in parallelograms, we said consecutive interior angles always add up to 180. This is not a parallelogram, but this line is parallel to this line. This is a transversal, so those are consecutive interior angles for parallel lines, which means we could have just subtracted 180 minus 124 and got the same answer. I would have totally done it the longer way, because I wouldn't have thought about that, but yes, that works. So hot. Miss Bai's smartboard overheated 3 times during first hour.
Like, oh my God.
Well, look, it'll come to you, I promise. You'll be complaining in a minute that it's cold. Okay. What about this? Quadrilateral ABCD has these lovely vertices. Show that ABCD is a trapezoid and determine if it's an isosceles trapezoid. How could we use coordinate plane stuff to determine if this is a trapezoid? Slope, right? And it's really nice. That's why I've been giving you graph paper. If you graph it, you just have to look at the slopes. I want to see the work, right? I want you to say the slope of CB equals the slope of, how come there isn't a letter here? Okay. The slope of AB equals the slope of CB equals the slope of AB. And it's really nice if you graph it that you can just count the slopes. Or you can do y2 minus y1 over x2 minus x1. But I hope we're feeling pretty good about doing slope at this point, especially if we've graphed it really nice on graph paper like this. So CD, I'm just going to go up 1 over 1, 2, 3, 4. So I'm going to say that's the slope of 1/4. And I'm going to check the one across from it, because if it's not parallel to AB, it's not trapezoid. I'm done with this problem. So what about on this one? If I go up 1, 2, over 1, 2, 3, 4, 5, 6, 7, 8, up 2 over 8 is 1/4. So we know that it has parallel sides. Obviously, we can look and see if the other two sides don't look parallel, but if we're trying to, like, prove this, we want to say, coordinate-wise, that they're not parallel based on their slope. So I'm going to go ahead and do their slopes as well. Well, even if it's isosceles, does it matter if their slopes are the same? You see what I'm saying? we look at their distances. But if we're trying to prove this with coordinate geometry, we want to say, not just because it looks like it, we want to say that this has a slope of 1, 2, 3, 4, 1, and this has a slope of 1, 2, 3. This would be a slope of these are not the same. So based on this, I can say ABCD is a trapezoid because CD is parallel to AB and CB is not parallel. How do I say not parallel? When I say parallel with the line to it this way, that's easy. Not parallel to DA. So I know it's a trapezoid. To determine if it's an isosceles trapezoid, which two segments should I be finding the distance of? The legs, CB and DA. We need to do the distance formula. So for CB, again, I expect to see a little bit of work here. It's not just yes, no. Distance formula, you subtract the x's that you squared them, and you add that to subtracting the y. So make sure you're subtracting correctly. So that's -2 minus -3 squared plus 3 minus -1 squared. So that's just going to be 1 plus 16, which is the square root of 17. And on this side, if I do the distance of DA, 2 minus 5 squared plus 4 minus 1 squared is going to be 9 plus 9. Is that true? Oh, that's so close, right? The square root of 17 is pretty darn close to the square root of 18, but they're not equal. So that's one, if you were just kind of looking at it, you might say they are the same. They look the same if I measure with my fingers, right? They look about the same, but they're a little bit off. So we would say they're not equal. So it's not isosceles because legs are not congruent. I think that's a real symbol. So that's the kind of stuff I expect to see when I give you problems like this. Lots of people are still just writing answers and not doing the slope and the distance formula. No, that's to be expected. Okay, one more thing about isosceles trapezoids. If you have an isosceles trapezoid, maybe it's just all trapezoids, isosceles. The mid segment is when you have the midpoint of the legs and you connect them. Let's write that. The segment that connects the midpoint of the legs of the trapezoid. So then maybe draw it. And it's kind of a cool formula. It's like, I do it. You can go to my YouTube, and I have like lots of videos, because for the last 3 years I've recorded in all my classes and I have uploaded videos. So I have like stuff all the way back from 2011. You can go watch some notes from Freestyle 2011. No views. No views. It's okay. Here's why I do it, because I despise dealing with that. Because when kids are like, what I missed? You just reteach me everything you taught yesterday when I taught for 48 minutes. So I can say, no, go watch the video. And after you watch the video, if you still have questions, then you. So
that's a lot of time.
But that's the expectation. So the mid segment is if I found the midpoint of each side of the legs, and I connected it, that is the mid-segment. That's not very good, it's approximate. Important things about the mid-segment. The mid-segment is also going to be parallel to the bases, right? Because it's just drawn connecting that. So that's going to be parallel to the bases, and it's 1/2 the sum of the lengths of the bases, which is kind of, I think, a cool formula. So if BE was the mid-segment of this trapezoid, not only is it parallel to AF and CD, but it's also 1/2 of the sum of AF plus CD. So that's pretty cool. Yeah, that's fun. Remember that one with some centroid or something? We got like 2/3 of the way. Well, obviously I don't really remember either because I don't remember which one. I think it was just in France. Something French. So questions like this, they can give you two of the three things. Either they could give you the bases and ask you to find the mid-segment, or in this one, what if they give you the mid-segment and one of the bases, can you find the other side? I'm an equation person. I would do and n is equal to 1/2 of the sum of the bases kf and plus jg. So I know nn is 30. I know fk is 20. And I'm looking for jg. People are really good at doing this in their head, right? Like they can think 20 plus what equals, and then half of that equals 30. That means you want the whole sum there to be 60. So some people in their head are just gonna be like, oh, it's 40. Is that true? Isn't it 40? Because you get half of 20 is 10 plus 1/2 x. Back that over, you get 20 equals 1/2 x, or x equals 40 because you multiply by 2 here. Right? This is one if you're really good at doing that in your head and you can tell me that it's 40. You don't have to do all the equation. But you can check really quickly. 40 plus 20 is 60, and half of 60 is 30. So that's the right answer. Make sure you pay attention to which one you're solving for in that. So I have a little check for understanding here, right? Let me just shut it back. It's comfortable. It is like a Sonic. No, I was like crazy. So try this one really quick. WXYZ is an isosceles trapezoid with median JK, so that's just through the midpoints there. Find XY if JK equals 18 and WZ equals 25. Well, I thought I could have beat this. Because I came to 40, I think. So, if you like, look like this. I mean, if I take the first term with the thing is over. If you look up, like, if I look on my phone, it doesn't ever give me that as an option, as a way to do it. When we had to go to, what's the school that's up there? Monrovia, Cascade, both of them? Are both of them that way? Anyway, when Parker, not Monrovia, Cascade. like the directions of Cascade were to go up 36 and cut over. But if I just look up directions to get to here from my house, it says the fastest way is to come this way. So, but that's traffic diversion. Wouldn't get me off topic. I got D. Did you get D? I did. I worked backwards in my head, and like I kept adding 25 and this number, and then taking half of it. Right? That's what it works. 25 plus 11 is 36, and half of 36 is 66. So you just gotta know that formula. Okay. Last thing about quadrilaterals: kites. Again, the definition of a kite. One, it looks like a kite. The definition are two sets of consecutive congruent sides. So, like, I think of like the two top sides being short and the longer two sides being long, because I think of a kite that you fly. Again, things about diagonals. The diagonals of a kite are perpendicular. The diagonals of a rhombus are perpendicular. The diagonals of a square are perpendicular. So we're going to see some of these things repeat themselves. But of a kite, the diagonals are perpendicular. And also, if a quadrilateral is a kite, then exactly one pair of opposite sides is congruent. Not two pairs, though, right? So you have to kind of take this and see what to find. Is it always these two sides, the lower sides? Yes. K is not congruent. So maybe the acute angles are always the ones that are congruent, it looks like to me. Alright, so if WXYZ is a kite, find the measure of angle XYZ. XYZ. What are you going to say? 73? Yes? Do you agree with that? It's the last one. One more slide. If NPQ is a kite, find the measure of NE. What do we know? Yep. What do we know about the diagonals? That's going to be 90 degrees. So what do we know when we see a triangle like this? Pythagorean theorem, right? We have a lovely right triangle, and they tell us that this side is 6 and this side is 8. Can we use Pythagorean theorem to find this side? Pythagorean theorem. We thought we'd forgotten all about that, right? So could I say 6 squared plus 8 squared equals n squared? Or 6 squared if you prefer. 36 plus 64. 100. So what does mn equal? Square root of that. Did they ask me to find what mn equals?
No, but you gotta find that so you can find the other one.
Because NP is marked congruent to NN, which means that NP also equals. No work due today. I think actual book work. Seems like a lot of problems, doesn't
Can you
it?
like cross out that stuff? Like we'll do 8 through 13 all. Just cross it.
8 through 11, you're just solving for one thing in one triangle. Like I promise, they're not that bad. 12 and 13 are the graph, like the coordinate ones. And then the rest of them, you're just solving for one thing. Mid-segment stuff, it's really not that bad. 42, not that bad. 53 through 57 are just always, sometimes, or never, which are good to think about with all these properties. So that's why I gave you all of those.
Skip that one.
So work on this. We'll talk about it tomorrow, and then we'll talk about whether or not the test is going to be Wednesday or Thursday. Okay.
Yeah.
3 minutes. I make a P, it changes it to a print. Doesn't do anything. Especially because I don't write my Q's. That's just a print. That's just a print. My maiden name used to be Estes, so I better write Cecil. And I always wrote my name like that. Like I always made the first S print and the second S cursive, and I don't know why, but like that's how I signed my name. And I never realized it until someone pointed it out. They're like, why do you write?
Wait, are you still recording?
Yeah, yeah.